Welcome students. Today we are going to study ultraviolet and visible spectroscopy, and in that we'll be studying Woodward fieser rules for the calculation of absorption maximum in dienes. Woodward formulated certain empirical rules for calculating the lambda max in case of dienes. These rules were later modified by Fieser in 1948. Woodward fieser rules can be used to calculate the position of lambda max for a given structure by relating the position of lambda max with the position and degree of substitution of chromophore. The longer the conjugated system, greater is the wavelength of absorption maximum. The intensity of absorption also increases with the increase in the length of the chromophore. Now, various types of double bonds in conjugation are described. The first is alicyclic dienes or dienes contained in an open chain system where basic unit is butadiene system. The next is homoannular conjugated double bonds. These are the conjugated double bonds present in the same ring, and it is also called homodiene. Now let us see some examples. Here you can see an example first. There are two rings A and B, and both the conjugated double bonds are present in the same ring A. See the second example. There are again two rings A and B, and both the conjugated double bonds are present in the ring A. There is no double bond present in ring B. Now let us study heteroannular conjugated double bonds. These are the conjugated double bonds which are not present in the same ring. Now see some examples. In the first example, see the conjugated double bond system first. A double bond in ring A, then a single bond and a double bond in ring B. So here you can see the conjugated double bonds are not present in the same ring. One is present in ring A and the other is present in ring B. So this is a heteroannular diene. See this second example. Here again two rings A and B, and the conjugated double bonds are present in different rings. That is, one is present in ring A and the other is present in ring B. See the third example. The same. Here are two rings A and B. The conjugated double bonds are present, one in ring A and other in ring B. So these are the examples of heteroannular conjugated double bonds. Now next comes the exocyclic and endocyclic conjugated double bonds. Exocyclic double bond is a double bond part of the conjugated system formed by any carbon atom of any ring but present outside the ring. Endocyclic double bond is present inside the ring. Such double bonds are shown in the following examples. Now see the first example. See the conjugated double bond system first. A double bond, a single bond and a double bond. Now there is a ring, and outside the ring there is a double bond present of the conjugated system, and this is known as exocyclic double bond. It is written, and there is one endocyclic double bond which is present inside the ring. See the second example. See the conjugated double bond system, a double bond, a single bond and a double bond. Now see the ring A. Outside the ring A, a double bond is present. So this is exocyclic double bond to ring A. Now see the third example. There are two exocyclic double bonds. See the conjugated double bonds. Now See the ring A, outside ring A, there is an exocyclic double bond. And see the ring B, outside ring B, there is a exocyclic double bond. So there are two exocyclic double bonds. Woodward and fieser rules. Each type of diene has a fixed basic value and the value of lambda max depends upon the number of alkyl substituents or ring residues on the double bond. Alkyl substituents you can make very clearly, and ring residues. So what is a ring residue? Let us understand it on the double bonds. Now ring residue on the double bond is a carbon-carbon bond, not a part of the conjugated system, but attached to any one of the carbon atoms of the conjugated polyene system. Next is the number of double bonds, which extends conjugation. And third is the presence of polar groups such as Cl, Br, Or, Sr, etc. The calculated and observed value of absorption for a particular compound can differ by 5 millimicron. Now here is a table showing the various rules for calculating the absorption maximum in case of dienes and trienes. So you can see the parent value of a butadiene system or a cyclic conjugated diene is 217 millimicron. For acyclic triene, 245 millimicron. For homoannular conjugated diene, it is 253 millimicron. For heteroannular conjugated diene, it is 215 millimicron. Now the increment for each substituent. For alkyl substituent or a ring residue, it is 5 millimicron. For exocyclic double bond, it is 5 millimicron. For double bond extending conjugation, it is 30 millimicron. For oxochrome, for OR, 6 millimicron. For SR, plus 30 millimicron. For Cl or Br, it is plus 5 millimicron. For NR2, it is plus 60 millimicron. For OCOCH3, it is 0 millimicron. Now we'll understand all these concepts by the help of example. Now see the example 1. Calculate the absorption maximum in the UV spectrum of 2,4-hexadiene. So first let us see. So let us make 2,4-hexadiene. So you see the structure here. 2,4-hexadiene. There are 6 carbon atoms. Now the base here is butadiene. So that is alternate double bond, a single bond and a double bond. So there are alternate double bonds in the system. Now the base unit here is butadiene. And there are 2 alkyl substituents. So I have shown the alkyl substituent by the help of arrows. So you can see 1 alkyl substituent on the left and 1 alkyl substituent on the right. So for your understanding, it is shown by the help of arrows, so you can clearly understand. Now see in the table, the base value for the butadiene system is 217 millimicron. So it is written 217 millimicron is the basic value, and for 2 alkyl substituents, it becomes 2 into 5 is equal to 10 millimicron. So here you can see in the table for alkyl substituent, it is 5 millimicron. So here there are 2 alkyl substituents, so it becomes 2 into 5 equal to 10. So add them. So the calculated value is 227 millimicron. The observed value is also found to be 227 millimicron. Now see the next example. Calculate the absorption maximum for this system. Now here, this compound is an example of heteroannular diene because the conjugated double bonds, they are present in different rings. So see the conjugated system here. One double bond is in ring A and the other double bond in ring B. So here the parent value is 215 millimicron. Again, you can see it by the help of table. So for heteroannular conjugated diene, it is 215 millimicron. Now there are four ring residues. So ring residues, for your understanding, I have shown by the help of four arrows. So you can see the four arrows. These are the four ring residues. So for one ring residue, the value is 5 millimicron. So for 4, it becomes 4 into 5, that is equal to 20 millimicron. So add them. So the calculated value is 235 millimicron. And the observed value is also found to be 234 millimicron. Now let us see the third example. Calculate the absorption maximum in the UV spectrum of the following example. So it is a butadiene system. So for butadiene system, we have already seen the base value is 217 millimicron. Now here two alkyl substituents are there. I have shown them by the help of arrows. So for 1, the value is 5. So for 2, it becomes 2 into 5, that is equal to 10 millimicron. Now you can see two ring residues. They are also shown to you by the help of arrows. So two ring residues, so again 2 into 5, that is equal to 10 millimicron. Now here there is one exocyclic double bond, and for one exocyclic double bond the value is 5 millimicron. So add all of them. So the calculated value is 242 millimicron. The observed value is also found to be 242 millimicron. Now next example is calculate the absorption maximum for the compound in ethanol. So here you can see two rings A and B. Now see the conjugated double bonds. The conjugated double bonds are present in ring A. So that means it is an example of homoannular conjugated diene. So from the table you can see the value for homoannular conjugated diene, it is 253 millimicron. Now see the ring residues. So there are 3 ring residues shown by arrow. So 3 into 5, it becomes 15 millimicron. And now see, there is one exocyclic double bond. So for exocyclic double bond, it is 5 millimicron. So the calculated value is 273 millimicron and the observed value is 274 millimicron. One more example, calculate lambda max for the compound. So here, see, there are 3 rings A, B and C. So here in the ring B, the conjugated double bonds are present in the same ring. So it is a homoannular conjugated diene system. So we will write the basic value 253 millimicron for homoannular conjugated dienes taken from the table. Now 4 ring residues are there which are shown by the help of arrows. So just see the 4 arrows and you can clearly make out the 4 ring residues. So 4 into 5, that is equal to 20 millimicron. Now see the exocyclic double bonds. So you can see there are 2 exocyclic double bonds. Okay, so the exocyclic double bond, one is present. Here you can see this is the for the ring exocyclic double bond to ring C is there, and one more exocyclic double bond to ring A is there. So these are the two exocyclic double bonds. So for each double bond, the value is 5. So it becomes 2 into 5, that is 10. Now you can see there is one double bond extending conjugation in ring A. So for one double bond extending conjugation, the value is 30 millimicron. So here the calculated value comes out to be 313 millimicron, and the observed value is 312 millimicron. Now next is bicyclic compounds. If a diene system is present in a bicyclic compound, then due to the strain in the bicyclic compound, 15 millimicron is added as the ring strain correction in the calculated value of absorption maximum. So here this is an example of a bicyclic compound. So here the basic value is 217 millimicron. Two ring residues are shown by the help of arrows, which you can see clearly. So this becomes 10 millimicrons. Now two exocyclic double bonds are seen here. So again 2 into 5, that is equal to 10 millimicron, and one bicyclic system, that is strain correction. So that is equal to 15 millimicron. So the calculated value is 252 millimicron and the observed value is 254 millimicron. So I hope now by taking and studying so many examples of all the types, the concept is clear to you, and now you can easily calculate the absorption maximum in dienes. So try some more examples. Thank you so much.